utilizing a combination of manpower, precision machinery, and robotics. The process can actually be completed with just a handful of personnel, thanks to the astounding levels of automation involved. Rolls-Royce has also invested a lot of time and money into the development of new turbofan blade technology. The company's latest advancement is the hollow titanium wide chord blade. This unique blade produces around 80% of the engine's thrust while maintaining an extremely light weight. The unique construction process involves fusing two pieces of titanium around the engines, then introducing air to expand the metal and create the hollow center. It takes around 80 different robotic processors to create and inspect the final blade. In the end, these have a much better strength-to-weight ratio than traditional blades. They, therefore, can generate more thrust without increasing the weight of the engine. Yet another area in which Rolls-Royce excels is engine testing. Before any of its newly developed or freshly refurbished engines is installed aboard an aircraft, it must undergo extensive testing. In 2021, the company finished its testbed 80 facility in Derby, United Kingdom. The state-of-the-art facility is actually the world's largest indoor aero engine testbed, with tens of thousands of sensors that can collect data at previously unimagined speeds. The internal area is 7,000 square meters, allowing plenty of room to evaluate even the largest engines. For decades, Rolls-Royce has led the way in testing technology. Across the company's various facilities, they've implanted hundreds of machines to test different parts of the engine, from the fan blades to the bolts to the ejection nozzle. The company also leads the industry in bird strike simulation. To test how well their engines can hold up to such an event, technicians fire a gelatin block into the fan blades. Speed. They may sound extreme, but these tests are the best defense against costly maintenance. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't.
How do you like that one? Have you ever seen it?
Oh.
No, I like it. Okay, so we were with the black and white thing. So let's see, this is the common arrangement of one of these engines. And guess what? There's no N3 indication here. We only have N1 and 2, unlike Rolls. Remember, there's a dedicated alternator that produces an N3 signal. So this is N1 and 2. The same is the same. The same of the assembly is similar. It's got the fan section, the low pressure compressor section, the high pressure compressor section, And then we have the high pressure and the low pressure turbine sections. So the bypass ratio is 9 to 1, meaning 9 times of airflow. It's going through the bypass flow, and one is going through the core of the engine. Now, talking about something we rarely see unless the engine is disassembled. There are 5 bearings. These are the roller types. So number 1 is roller, 2 ball, 3 is a ball type, 3 is roller, and 2 more roller bearings are found in the back. Also, it obviously comes with a gearbox, which is connected to the N2 rotor. And is connected through the transfer and the horizontal drive shafts. If you disassemble the fan section, you will see that there's a spinner. The disc with the fan blades is here. So it is accommodated inside the fan case. And then the fan frame is followed, and this is the fan disc. And the rest of the assembly is here. Just for the fan blade area, this is a closer look, so you can see how it is installed. So you install the fan blades, and these are the retainers that will hold them in place. And there are some pieces of metal that also will come as part of assembly. This is just the information about the how it is coupled. So in this case, the fan case, the whole thing is coupled through to this fan disc and this fan hub frame like this. And this is what the design tell us that should like if we go inside and see how these parts made together. Also, there are some weights typical just for balancing. So in fact, you have to weight with balance these fan blades, the arrangement, and also the LPT 6-stage blades will need to get some balance done. So normally what we do is see that the balancing is correct here. So the balance for the turbine required that the section is disassembled. So we normally get this fan blades assignment whenever something has happened, and say one of these blades are damaged. So we come with a procedure, and we use this balance screws. But the main thing is just to know that the LPT 6-stage is also balanced. The accessory drive, I said it was connected to N2. No, it's connected right here in this section. I was wrong. So this is a typical gearbox. So you can see some of the components. There's a loop and scavenge pump on the left side. IDG fuel oil heat exchanger is there too. The control alternator is in the face of the gearbox. The backup generator on the back side too, and the hydraulic pump is on the opposite side. And there's a borescope cranking pad. So you need to remove this in order to rotate the engine and then have it borescoped. If you come and see what components are associated to the mounting of the gearbox, is the starter valve on the left side. Hydromechanical unit is also there. It is installed together with a fuel pump, and there's a main fuel oil heat exchanger also there. So these are in the opposite side. So this is looking forward. The borescope access port, there are plenty of them. I guess this is related to what the MRO maintenance do. These guys, the specialists will know that there are certain places where they can inspect the core of the engine. So there are plenty of them. So you just have to remove this plug, and the shape of these and the square block segment will tell you this is a borescope plug. So you just need a speed drive to remove it. Now, next section tells us a little bit about how this engine fuel and control looks like. So we know that there's a pressurization, how do you say that? Pressurizing filtering and injection function. Also, control is doing metering sensing, and it's got some power and interfaces. And also, it has means for indication. So the interfaces that are involved with this system is the engine indicating, the engine exhaust, the oil data, engine starting, the electrical power, engine ignition, the air data, and engine controls. And all this will share information through the engine data interface unit. Remember, this is what converts signals into information that can be sent through the ARINC 629 buses to all other users or all other components and systems like AIMS, flight deck controls, the FSEUs, the ASCPCs, and the card files. So this is quite similar to what we saw in the other trend presentation. So this is the same. We have the main fuel pump, and we have a HMU, and we have some fuels sent to the fuel nozzles, and other section of the HMU will be responsible for sending additional fuel to drive servos. And obviously, it needs to send information about how much fuel it is going through it. So that's why there's a fuel flow transmitter, and this signal will be sent to the computers, the FMCs, and to the ICAs, so you can see how much fuel it is consuming. So you can see installation of fuel nozzles. There are 30 of them. And if you look up there, they appear like this. And this is the section where it is this assembly can be found. So remember, 30 fuel nozzles will be there, installing the same type of manifold. So the fuel filter and the main fuel pump will be right here. So meaning it's on the right side. And if you have a closer look to it, well, it appears like this. This is a different design. This is a filter. So it has like a ratchet lock. So you have to press this one to release when you turn to remove it. So this is unique to this plane, and I haven't seen any other brands using the same type of locking. So another look of the nozzles is here. So this is the arrangement. It says there's an outer spray tip and inner spray tip. So it is designed so the flow of fuel that is injected into the burner is evenly spread. And there are two manifolds also. So if you come inside the unit, you will see how it works. Remember, it is combined. So you have the main fuel pump, and it is attached to the HMU. So it will receive, this HMU will receive high pressure fuel, which is going first to the heat exchanger, fuel oil heat exchanger. Also will divert some of the fuel to the IDG, fuel oil heat exchanger, and also the fuel oil heat exchanger will put some fuel available for the servos as a separate arrangement. So the rest of the fuel will go through the FMB, and once all the logic here, all these passages are followed, the fuel finally will go to either 10 nozzles at first and or 20 nozzles. We'll see that, but I believe we have to see that the fuel, this 10 nozzles will receive the fuel first when the engine is cranked for initial start. So we don't overheat the engine by putting too much fuel in it. And again, this is where the fuel flow transmitter is installed. So again, this is what happens inside of this unit. So it's typical. We just need to get a lot of pressure there, put the fuel at the right temperature, and then send it for the fuel nozzles or send it for servo used. What's it? All right, so if you come to the flight deck, this is what is involved when you talk about what controls the fuel consumption or yeah, what controls the fuel flow. So this is the EEC. Remember, this EDIU will convert all the values that are obtained from here into readable information that can be transferred to all of the airplane systems through the 629 buses. And these are the controls in the flight deck. So firstly, you have to make sure that the EEC will work in the normal mode. So these P5 switches must be set to normal. That's the first thing they do. And then when they are preparing the flight, and then in order to start, all these are the switches in P10 that will allow air, will send a signal that the engine is started, so the valves open. And this is the P5 ignition selector. So when you crank the engine, you first have to come put this switch to the start, and when the proper RPMs are reached, then you put the switches in the wrong position to open the fuel supply. Finally, if you are on the ground and you are supposed to check something, you need to look for maybe a test. P61 is where you will find the EEC maintenance switches. There's one for each engine, and there's one for each. So you just have to lift this card and put these switches to the test side, and it will activate the power. It will bring power to the EEC. Also, the alternator, the control alternator, will supply power when the engine is rotating. So this supplies all of the functions, supplies all of the power to the functions of the EECs. So it actually controls everything that this HMU needs to do. Also, ELMs will be related, and the EEC will be, there's no right function for shutting the supply of a fuel whenever an emergency happens. So if you pull these fire switches or fire handles, you will drive this solenoid closed inside here. And that information also goes to ELMS. So this is the general layout of how the controls are made for fuel. So locations for to locate the components are once again displayed. So you can see here there's a closer look of the control alternator. There's a P0 static port. This is a signal that just gets information from the ambient pressure and sends it to the computer. There's nothing to do about it. Also, the T12 sensor, again, is located here before the fan blades. The EEC is here. T3 sensor, one of the signals it is required for the EEC control, is here. Another view of the main fuel pump and the HMU, just a single unit. So it is just beside the starter. So you cannot miss this assembly. Locations of the controls that I was showing earlier is P61 for the main switches, P5 the EC mode switch, the flight deck. I'm sorry, the EDIU is also in E1-5. And that's for the left one. But if you come to the opposite side, if you look forward, will be the place where you will find the right EDIU. So remember, these boxes will just make the translation of the information obtained from the EEC in order to have it sent to this other system through the 629 data bus. So let's stop right here, guys, and we'll continue with some more features about the interfaces for the engine and fuel control. So take 10 and come back.
Yeah. Querían que nosotros empezado, güey. ¿A tu hijo? ¿Cómo? Sí.
Nosotros quitamos una válvula de nitrogen generators system.
¿En la NGS? ¿En el 30? ¿En el la liga? Sí. No, vamos a
No, en el noruego.
¿En el noruego? La
De
válvula.
las últimas 4 cosas que pidió que se robaran. ¿Era una válvula?
No recuerdo, creo que eso lo hizo Ángel, pero la verdad no te mentiría, Lalo. Sí, Ángel estaba viendo lo del NGS.
Sí.
No, sí, fuimos nosotros que dijimos que pedimos que le hicimos
¿Te
pruebas.
quitaste la luz de allá arriba?
Ajá, sí. Y quien la quitó fue Dani. Sí, se fue
Ah, Dani.
¿Por qué?
Ya llegó.
Sí, nosotros se la robamos fue Dani.
Sí, ¿verdad?
Sí, fue Dani. Yo hice la prueba, le dije que la quitara. Y ya se echaron para que quitara la luz de la punta. Yo quito la del ala. La del ala. Quito la de la otra ala. Y después de eso, ya le dije a Dani que le diera a Shanna porque no podía.
Con la de la cola.
Ah, la de la cola. Ya, no sé. Mientras yo estaba haciendo las pruebas, quitando los motores, ellos estaban quitando las luces. Sí, sí, sí. Fue Dani. Pero, ya tengo ganas de regresar al jale, Juan. Ay,
Eso falta, ¿va?
ya. No me das sueño la noche, ¿tú crees?
¿No?
No, no me canso. Como estamos aquí, dando movimiento.
Sí, pues. Sí, yo también me tengo para dormir. De allá para las 3 de la mañana. Digo, hoy me asomé en el reloj a las 3 de la mañana.
No manches.
Pues ya, o sea, estoy así nomás dando vueltas y pensando cosas. Y pues, qué rollo. Ya me asomo en el reloj y eran las 3 de la mañana.
Ajá.
Y así me pasa, sí.
Pero es porque ya estás
3 de la
acostumbrado a dormir
mañana,
allá, ¿no?
2 de la mañana.
Y yo también. 5:30, 6, ya estoy despierto.
En mis días de descanso, pues sí, bueno, 5:30. Es como que,
Está bien gacho, ¿no? Y ya no puedes dormir, a pesar de que te acuesten. Ya no sabes qué hacer.
sí, mi esposa compró una bicicleta de esas estacionarias y ya este último día que sintió que estaba yo ahí nomás dando vueltas y vueltas, me dice, ya que me dice, no, oye, si no te puedes dormir, levántate ya en bicicleta, por lo menos haz algo". Hacer ejercicio, si ya no puedes dormir, levántate, haz ejercicio, bueno.
No manches. Ya sé, un chico cuesta cabrón, no se acostumbra.
Ya no tiene tienes agua en tus tinacos, ¿eh? No sé si tus huéspedes ya hicieron el reclamo directo.
¿Tus hijos ahorita están de vacaciones o no?
Todavía,
Bueno,
pero no hay agua en tus tinacos. Entonces,
Sí, sí, pues en verano van a ser más de 2 meses, creo. Ajá.
3 veces creo que algunas escuelas les dan vacaciones por lo menos una semana, ¿no?
Sí, no van a hacer como tal, no. No, van a tener una semana.
nada, esa pipa. Hay un tema complicado ahí para hoy, que es puente.
Apenas otra semana.
Entonces, voy a cargar un tinaco. O me confirmas, tus huéspedes ya están por
En diciembre, bueno, sí, fueron 2 semanas.
cargar un tinaco. Si ya están por irse,
En diciembre, enero,
si es así, si no vas a
en marzo.
mañana, pues me confirmas para
Y
redistribuir.
en mayo salen, terminan el ciclo escolar.
Y 2 meses, ¿no?
24 de mayo salen y regresan hasta el 5 de agosto.
Es bien chido aquí.
Todo junio, todo julio, una semana de agosto y una semana de mayo.
Está bien chido aquí para estudiar.
Como 2 meses y medio,
Sí.
2 meses y medio de vacaciones. Oye, les enseña chido, o sea, sí tienen clases por acá, pues.
¿Y el inglés? Ya acá lo hablan chido.
Más o menos, casi no hablan. No, mi niño, acá nosotros mi niño casi no habla. Pero lo que dice mi esposa es de que, o sea, como está en lo del fútbol, y luego lo vemos que está así, ¿no? Se medio pega así, así con sus cuates, ¿no? Se pega ahí, como que se pone a platicar y dice mi hijo, pues, ¿qué tanto les dirá? Pues no se supone que no habla. No se supone que no habla inglés y pues ahí se pone según él a platicar con ellos, ¿no? Y luego les preguntamos, ¿eh?
Se aprende bien rápido con los años. Tengo un sobrino que lo trajeron acá como a los 6 años y el año ya hablaba. O sea, todavía como que lo hablaba medio raro, pero ya sabe entender con sus amigos.
Sí, claro. Sí, pues,
Tal vez se prueba por ustedes y ya con.
ajá, puede ser. Sí, porque con nosotros casi no hablan. La que más habla con nosotros es la niña más chiquita. Ya lo que decíamos, o sea, la más chiquita resulta que va a ser la que mejor va a hablar bien rápido. La más grande tiene mucho vocabulario. O sea, tiene mucho vocabulario. Se pone a leer libros y ya, sin problemas, no sé si todo viene bien. Una que otra palabra, oye, ¿qué es esto? Ah, ¿qué es tal cosa? Y sí. Pero ya se pone a leer libros. Entonces, ella tiene mucho vocabulario, pero no habla mucho. Sí lo entiende, pero no habla mucho. Mi niña más chiquita es la que más habla, con nosotros, ¿no? Pero el niño, pues te digo, pues ahí en el fútbol, pues ahí se pone a platicar con sus amigos. Ahí, qué rollo.
Pues yo creo que se come con ustedes.
Sí, van a decir. Sí, porque también en su clase de inglés, pues la maestra dice que van muy bien. Los dos chiquitos, los de la primaria, bueno, muy bien, bueno, sí, estaba yo por ahí. Sí, sí, que van bien. El niño como que no muy bien le interesaba mucho así como tal, que una aplicación y ponerse a aprender. ¿No? Así, la más chiquita así, que con la aplicación y así. Y la más grande pues, se pone a leer y todo eso, se pone a ayudar. Pero el niño nomás no, como que no le interesaba mucho eso de la aplicación y nada de eso. Pero dice la maestra que va bien.
Es que se aprende, bueno, yo lo he visto con mis sobrinos y se aprende. Se ha aprendido de volar. Sí, en la escuela. De hecho, hasta les dicen que en su casa les hablan en español y en la escuela aprenden para que no se les olvide el español. Gracias a usted con español que ya él va a aprender inglés en la escuela.
Sí, claro. Y luego la otra que hemos visto que también, por ejemplo, ahorita que están viendo que décimas y no sé qué tanto, ¿no? Todo eso. Y luego dice mi niño, oye, pero es que pues, yo me sé esas cosas de fracciones en inglés Dicen, pero pues no sé cómo se llama el español. No,
No, pues es muy efectivo porque no,
es algo
no lo están viendo. Sí,
ajá, es algo nuevo que están aprendiendo y yo me lo sé vivir, pero ya en español sé cómo se llama.
sí, al rato van a saber, ¿cómo es esto? Te van a decir, ¿en inglés o en español? Tú vas a hablar en español, papá. Te van a decir. No,
Sí,
man.
son terminologías nuevas que no habían visto en clases en español siquiera. Pues. Entonces ahora dice, oye, ¿y ahora qué?
¿No se les hizo pesado el cambio? Pues, bueno, no te dijeron, o extraen mis compañeros o algo.
No, sí, justo. Sí, no, sí estaba bien emocionado. Yo a mis niños allá, pues, nunca los había tenido bueno, nunca los he tenido en escuela de pago. Y pues a mí son prácticos, son de gobierno. Pero aquí, pues, la escuela, pues ya ahí está, en su línea también. No, la escuela está bien padre, o sea, está bien padre.
Me hubiera gustado ver una escuela así de chavo.
Sí, sí. No, 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 ni siquiera la escuela aquí.
O sea, y mis niños se emocionaron mucho con eso, pues, o sea, mi niña igual, la más grande, pues la de la prepa, dice, no, pues es que es como en las películas, bien emocionada, ¿no? Cuando llegaron. Es que es como en las películas.
No, existe chido por ahí. Te tuvieron que decir que tienes. Sí, aquí no me hubiera gustado, ¿no? No, estudiar aquí en una escuela así. Oye, no manches, pero con ese cara, a pesar de que sea de gobierno, tú terminas pagando, ¿no? ¿Algo?
Gratis todo hasta los high school, ¿no?
¿Tú? Ya la universidad es lo
Parecido, a educar, a veces.
De hecho, creo que lo hacen así para que ahorres toda tu vida para cuando llegues
Para que puedas pagar la
la universidad.
Muy bien, chicos. ¿Qué tal si continuamos? ¿Están listos?
Yep.
Okay, guys, so let's move on. We already mentioned a little bit of the features of certain components, so I will show you some short videos that came from the factory, and they dedicated information regarding certain components servicing or removal. So I mentioned the fuel pump, for instance. So let's see how they do. Forgot that.
¿En cuántos segundos dices? ¿3?
That was one of them. So let's move on with some more details in this presentation. So this slide is showing the interfaces within the engine, fuel flow, fuel and control with the other systems. So the ESC will interact with the systems through the EDIU. So it shares information with AIMS, with the FSEUs, with the pressurization controllers. Also send information. It sends information to the card file and also interacts with OPAs. And on the other side, it will send information or will be powered. Well, better said, it gets power from the EEC mode switch, so or the EEC maintenance switch through ELMS, and ELMS also will assist to operate these valves to open and close them as required by the EEC. So the engine fire switch, fuel control switches, and the start selector switches also are involved in this section. So these are all the interfaces related to this engine. Another interface group of components are the engine speeds in 1 and in 2, the engine component positions. These valves are also integrated in this package. Thrust reverser components. The rest of the components in the engine fuel filter, engine fuel system is it's like a fuel filter, the differential pressure indicator, the fuel flow indicator, fuel manifold pressure, also the electrical systems, the hydromechanical unit, temperature signals, pressure signals, start air valve also is integrated in this package. The engine ignition exciters, and this control alternator will power the systems inside the EEC. This engine rating plug and the config plug, they have information that the EEC needs to know regarding power setting. It is set yeah, so all of these components will be referred later on in a different slide. So the config type box is on the left side of the engine. The engine serial number is put into the EEC through the special functions page on the mat. So you have to go download anything new. You need this plug to know through the mat. So this config box supplies data on the correct version of the engine hardware to the EEC, and the electrical connector on the box attaches it to the EEC. So this config box is here, is located on the left side, about 9 o'clock, and it is right next to the N1 speed sensor. And you can see the data plate will be here, also around 9 o'clock. Connectors, well, this is the arrangement of them, so just locate for each of them as they are labeled. Also, there are pneumatic connections. For instance, we have a P3 Bravo, which is the HP bleed duct pressure signal. Also, P0 is a ambient pressure signal that is attached to this coupling. P25 also is here, and the PS3 stands for the combustion inlet static pressure, and so on. So these are all of the connectors that you will find in the EEC. Okay, we're not going to go inside. So this is the logic inside the EEC. So that's pretty interesting, but there's nothing we can do on it. The field control alternator is here, and it is located in the forward flange or forward face of the gearbox. So it has 2 connectors, and this is what attaches to the main gearbox. T12 sensor, I mentioned that is here in the forward side about maybe a 12:30 clock position. So if you remove this cover plate, then you will find these lines. So you can disconnect this sensor from here. Next one is the P25. And well, it is also on the left side. And if you take it off the engine, you have to unscrew it. So once you take it out, it will appear as this. So that's 225, another signal among many signals that is present in this engine. The T3 sensor will be here on the opposite side in the core section here. So this is a typical arrangement right here. P0, this is just a line. This, I'm not sure if it's flexible, but anyway, there's nothing to do on it. Just make sure it is clean as any static port. And it's on the right side. Should be another one on the other side. There's, yeah, just look for the 2 of them. They are installed in the same area, opposite sides. Something they call the bleed bias flow sensor is here on the right side. So this is just another component so far. More sensors. Fuel filter delta P sensor is here. So it's right on top. This locking ratchet, the design is there because in the old types of filter, the pump filters. Remember, once the cover was tightened, we had to use lock wire to secure it. So they changed, so there's no need to use a wire. So that's the reason this ratchet type is there. So it will be no motion. So this comes loose. Well, more seals, and this is the arrangement. So it is how the HMU is presented. Doesn't give me a good picture. It's time to see. This is the internal operation of this HMU. Again, we don't see anything that is happening inside. So we only know that it just needs to get the fuel at high pressure, so it can deliver part of the flow to the actuators. There are many actuators like a HPT and ACC valve actuators, or the VSVs or the BBBs actuators. And also, it will be responsible for provide the fuel nozzles with the fuel supply. So this is just what happens inside in a basic presentation. The IU changes the ARINC 429 data to 629 format, and also changes 629 to 429. So this lets the EEC transmit and receive data to and from the airplane systems. So there's one per engine, meaning that all information that goes around the EEC it's delivered through 429 data, and this is responsible to translate that so the other systems know what's going on here. So it's just a translator. The power management is what supplies power to the computer and so on, but okay, that's internal. So EDIU, this is an internal arrangement. So you see one side, it gets information from the 429 out or in EEC buses, whatever is happening here goes in this language. So this box is there just to translate, and then it distributes that information through this 4 systems, 6 to 9 buses. So when the normal mode switch is it's there. The N1 is what is used to control the RPMs. So it says in this mode, it uses inlet temperature and TLA to set engine speed. So as an example, you will see you can put the thrust levers at a specified position to set the thrust rating. And these levers are at 82.5 degrees of the thrust reverser lever angle. The engine is at takeoff thrust or maximum continuous thrust. That's an example. And the alternate mode N1 Okay, so we don't use N1 when the switch is in alternate position, so it's not normal. So that's this is just an example of what this switch can do. So if we refer to the EEC maintenance switch again, we say that it lets power to go from normal power sources in operations to the EEC. So it connects the airplane AC power to the EEC without operation of the EEC control logic. So it also sends a ground test discrete signal to AIMS. What it does in general is that the switch is there to activate the EEC if the engine is not operating. And indications now are visible here in this slide. So this is where the N1 is presented in ICAS. Now they are showing thrust levers. So these are also the EEC maintenance switches in P61. Okay. Now let's talk a little bit about engine fuel flow indicating. So you know where to find it. If you come to the secondary display, this guy is going to be responsible to produce that signal. So it is located on the about 4 or 5 o'clock. It is here, and it's sending information to the secondary engine display. So fuel flow will be shown here, just below the N2 reading. And also you can come to the performance page, and then you will find the same thing here replicated in this other screen too. If you come to the CDU, we didn't cover that earlier. You can also see how much fuel is consumed. So this information is just by the FMC for navigation purposes. So the pilot knows if those engines are burning more or normal fuel upon certain time span. So it'll tell what is the quantity that is left in each of the tanks, and is also showing what is the speed, the rate of flow that both engines combined are consuming. More controls. Well, again, we know there are thrust levers, fuel control switches, auto throttle thermal motors, the thrust lever switches, the switch pack, and the TLA resolvers. These are the ones that finally will send any lever position to the EEC. So there's nothing new on the horizon. They are in the same typical position as all Boeings. Thrust levers, same thing. This is another view of the TLA resolvers and how it is related to the EEC and the HMU. The fuel control switches again, thrust levers. Well, there's nothing new. This is another part of the arrangement. So TLA resolver is also part of the backup that is attached to the auto throttle servo motor. So once it gets information from the FMC through the thrust management computer, anything that is directed and commanded to the HMU will come here first. So once this is selected to the proper position power setting, it will make this to move as required, and this TLA resolver will finally send information to the EEC. Now they are showing also a takeoff go around trigger. These are in front of the levers. So there's one per lever. Some more things, a lot of switches that are here are not visible from, they are not visible from the flight deck. You have to come inside the any compartment and reach for the pedestal, the P10 area from beneath. Okay, let's see what else is shown. Okay, these are components related to the throttle lever, the auto throttle assembly. I show you. So these are the internal components of this assembly. Also, I don't believe you are related to this kind of inspections very often. If so, it's only inspected, I guess, every time higher check is performed, or unless one of the switches that are inside is fault. All right, this is another view of the TLA resolver. So it varies the voltage here, and this is what drives the HMU through the EEC as the throttle moves it. All right, so this is the internal part of it. No, actually it says how the cutoff switches are controlled, and when they are moved, they will tell how the power will go through these relays and so. So everything is happening here inside the P 110 panel. Okay, so controls, let's see if there's something. Well, at this time, I can say that you can get secondary engine display information. Also, this engine information will be in the performance maintenance page, EPCS page, and the propulsion data limits also in maintenance page, and the maintenance page will display also the exceedances. So this is not all it can show. So maintenance pages are not shown in this slide yet. So I guess we will see them later on. For instance, this is a EPCS page. So the resolver will send information to the EPCS, so you can track if you move the lever, what is the actual position that you selected, so you can see both channels in the EEC will have a reading. So usually you have to read the same. So what else is here? More indications. So what you see in this in the ICAS screens is information that is produced by the N1 speed sensor from thermocouples, from accelerometers. These are tied to the air vibration monitoring system. Also, N2 speed sensor will produce signals. And the ABM signal conditioner also is related to the system. So we get speeds, we get exhaust gas temperatures, and we get a vibration, airborne vibration values. So these are indications that are dedicated. So we can check them out in the screen. Here, the next slide is showing components that will be found on the left side as well. For the, let's say, the bearing number 1 accelerometer connector is there. The N1 speed sensor, the one we saw in the previous slide, it's shown in the, that is on the left side of this engine. The turbine accelerometer, same thing on the left side, along with the 1049 thermocouple sensors. Then bearing number 1 accelerometer is in the engine near bearing 1, but you can only get access to the accelerometer connector, so there's nothing you can do on it. Also, there's a remote charge converter, also referred as RCC, and is in the strut under the fairing 2. We'll see it. So they are all here. So remote charge converter is here. The accelerometer is here. The N1 speed sensor is here. And the bearing 1 accelerometer connector is here. Remember, this remote charge converter is the one that is tied to the ABM. So it converts a signal that is detected here. So readable data can be obtained in the ABM. If you go to the other side, you will find the N1, no, I'm still M2, sorry, and the T49 sensors. And its precise location is here. So there are T49, there are 4 sensors for this signal. So here's one, and here's the other one. And since they say 4, the other 2 are on the opposite side. The N2 speed sensor is here. So N1 speed sensor uses signals pulses to measure N1 rotor speed, and it is at the 830 on the fan hub frame outside. So you get access to the sensor with the left thrust reverser half open. So if you need to replace this, you will find it here. And this is the N1 speed sensor in more detail. So just look for it, 830. N2 tachometer sensor is this one. So you just remove it from here as well. So in this case, if you're looking forward, you will be found right here. these are the typical readings that are displayed whenever something happens regarding normal or abnormal operations. So you can see things like N1 red line, those are references. N1 target reference will be shown in green or magenta. N1 command. This is what happens if you move your thrust lever and the EEC is powered, even if the engine is not operating, it will move this segment, this sector, to the commanded position so you can see it, even if the engine is not running. The actual N1 is shown here. N1 reference green, N1 reference will be displayed in green, and the thrust reference mode also will be in green, and the max N1 amber will be amber. So the same thing, if you go to the N2 indicator, it will show like this. And when N2 red line will be displayed here, and the actual N2 information also will be displayed here this way, and the fuel flow will be here. So this is secondary engine display, and this is the primary display, the ICAS display. So just as a reminder, the N1 and N2 speed signals come from the speed sensors. So each speed sensor has 3 outputs, and the LP and HP shafts each have a wheel with teeth that cause electromagnetic pulses as they go by the speed sensors. The N1 speed sensor output goes to the channel A of the EEC, and the other one goes to B. And the third speed sensor output goes to the EDIU. So 2 channels are signal inside the EEC for redundancy, and also the third one will be the one used for communicating with the other systems through the EDIU. Still, they all need to go through the EEC in order to have this EDIU supplied with the 429 data bus. All right, so 2 signals will come to each of the channels. One is A, one is B, and the next signal will be sent to the systems. So you can see channel A and channel B will generate 429 data and will be transferred to the EDIU and then to the systems. And the third sensor is not delivering any information through the EEC. It goes directly to AIMS, and also it needs to be converted. The information needs to be converted through the EDIU. Also, as we review the N2 speed sensor signal, 2 of those wires will feed channel A and B, and the third one will go to the ABM signal conditioner. So if you stand right there and see how many connectors are there, how many lines are installed in this assembly, you know that part of them will need to feed information into the EEC, and both channels need to know what is the reading that is picked up from here. And it's very simple. So there are always 3 lines going through there. So I guess there's one connector and there are 3 wires. Now the EEGT signal comes from 8 probes, typical probes. So that's what refers to the T49 probe. So it also they also send information, and it goes separately, channel A and B, channel A and B also on the other side. So the reason they split the signal to each channel is just to make sure there is some redundancy logic inside. So the computer doesn't get lost in the process of knowing what's going on with the system. So then it can inform ICAS and cross-check with AIMS after the information has been processed to the ICAS, and then you will see the EGT display showing the actual value. Now, finally, they put some color, so you will see EGT red limit line as a reference here. EGT amber band also will be used as a reference. The actual EGT means white line, and this will move as power increases. So the whole spectrum containing this shaded segment of the indication will come to a higher level or lower level depending on the engine power. So this is not just reference, this is actual power. When you see a EGT start limit, we have another red limit line. You need to observe when you are starting the engine that this limit is not exceeded. So anything that happens during an engine start must be below this red segment here. Otherwise, we'll say that the engine was overheated during the start. Okay, so these are the EGT probes or T49 probes, so you can look for them. So you start counting from 2 o'clock, you finish at 5:30, 6, and on the other side from 6:30 or 7 to 9 o'clock. So these are where they put this EGT probes, T49. So same thing, this harness is arranged so the 2 of the channels in the EEC get information. Same thing, they go through EEC and then EDIU, and systems will receive through 629, and then AIMS will be involved. So the process is always the same, EEC and then EDIU in most cases. If you open the engine, you will look at C49 that is located here at the exit of the HPT, right in front of the LPT. So this is where this information is coming from. For engine vibration levels, the ABM signal conditioner unit is used. So it gets whatever information comes from the N1 bearing accelerometer, and also the turbine accelerometer will feed. So once this unit gets a proper value of the electricity that is generated by the piezoelectric effect, it will convert. So the ABM signal conditioner knows the level of vibration that is detected for this guy here. And again, N1 and then speed and 2 speed sensor will appear like that. So remember, one cable, one connector will feed EEC independently, and the third will go to AIMS. So the accelerometers again use piezoelectric crystals to get the input to the engine for the engine vibration and send it to the remote charge converter. I already mentioned that. So it is found here on the engine strut. That's where the remote charge converter is located. And the N1 bearing accelerometer will be here, left side. Yeah, it's hidden, so you have to really look inside to get to the place it is installed. And the turbine accelerometer will, you can find it here in the outside upper part. It's maybe about 11:30. The signal conditioner unit is found in E2 and E1 opposites, and the aft cabinet. So what it does is just to calculate, it calculates vibration and no, well, firstly, it needs vibration and speed signals, and then it calculates the engine vibration data, and engine balancing systems also will be using this ABM. What else? Well, this is another description in schematic about what happens. So same thing, you get the accelerometer signal, you feed the RCC, and the RCC will send information to the ABM. And once calculation is made and it knows how much vibration is detected, it will send this information through the system buses to the AIMS. ABM is indicated in the engine secondary display and performance maintenance page as well. So you can see here the regular values. So normally anything that is vibrating should be below 1, but the manual will tell you what is a proper normal value. So you will see if the exceedances readings are present, that there will be a change in color of this box. Also, you can see the same reading in the performance maintenance page here. So in this case, it says that the channel B of the left engine computer is picking 0.20 units of vibration, which is pretty normal. But in the other side, N1 fan is delivering a 0.0 reading in the B channel, meaning that the vibration is too high. So at the end of the day, it will tell you what is the source of the vibration in the engine. So that's the reason this performance maintenance page is there for. For balancing, I mentioned that there's a feature that you can find in MAT. So you use the ABM to carry out this procedure. I guess you have to arm it. I never did it. I didn't do it. So perform balance or to calculate the specific balance coefficients, can be selected in the matte display for each engine. So you just select here, continue, and it will give you more instructions. Well, and this slide is only stating how to carry out this balancing procedure. So we're not going to go over this. This is a specific task. So we have to put or rotate those blades in regard of whatever this is instructing the maintenance personnel to do. So they rotate, and this will detect, so it knows how much weight it requires when that happens. But all these indications will be present as you start the balancing option. There's an alternate procedure to balance. So in this page, you will find some useful data. So you have front vibration values, some predicted front vibration values. So it's the same in the rear, yeah, on the back. So this is just for the N1 limit, but it also has additional indications in the opposite side. So these two values are calculated prior to let the screen know that what is the proper value. So Matt will do that through the ABM. So it doesn't really work the same way as when you are balancing your car tires, but it's I guess the basic description that I can make if we compare one of these car systems with this sophisticated process here. But it's the same, just measure how much weight is on one side and how much weight is measured on the opposite side. So also there's another detail. So there are more instructions about what to do. I have to be honest, guys, I've never balanced any blades at all on this type of engine. So probably you are more related to these tasks, not necessarily for the GE90. But if so, you know what I'm trying to explain. All right, so some other sensors that will come in place here are the P25 and T25 sensor. This data is not indicated in the flight deck. And not all engines have these other gas path sensors. So these are available from the engine manufacturer as a customer's option. So if they are there, P25, so let me go back here. Yeah. This is one sensor. So again, any information that comes from here, we go through the EEC, the EDIU, and then through the AIMS in the same way. What you see in the N2 or the secondary, I said N2, what you see in the IGAS and the secondary engine displays is N1 for the LPC rotor speed, the EGT exhaust gas temperature, N2 for HPC rotor speed, the fuel flow indication, oil pressure, temperature, and quantity. And vibration also will be displayed in both of these screens. So here, and IGAS displays showing N1 and EGT, and all of the other readings will be found in the secondary engine display as they appear in this slide. So again, in two, fuel flow, oil pressure, oil temp, oil quantity, and the vibration will be here. Exceedances are always displayed in the engine exceedances maintenance page. So it will tell you what value was exceeded at what point of the operation, and how long it stayed there. So it says, for instance, the value was exceeded when it was at 840 Celsius for about 0.3 seconds. And it says what was the, it was tell you that this is the result of an EGT red line, because it was reached over the max, even though it was a transient fault, maybe just for an instant. The computer will pick it up and will show you to the EEC, the engine exceedance maintenance page. Vibration is not shown here, so you have to come back to the performance maintenance page to get it. So again, you can see all these values per engine. More information regarding chapter 23, 73, 77, and 79 also is displayed here. The EPCS page shows a position of some of these components. All of them are tracked, and you can read the actual values as well. So it is reflecting the rotor speeds, the thrust lever angle, the thrust reverser position, the engine pressures and temperatures, and the compressor control components. Also, you can see the engine fuel control information regarding if those valves are actuated or not. Oil system parameters, and you can see whether the filters are normal or not. And there are more values for temperatures. So both engines will receive information that can be shared in the EPCS maintenance pages. Propulsion data, let me see what I can tell you. Well, this what is limited, or at least is tracked for limitations, are RPMs, EGT, and in the oil systems, the pressure, temperature, and quantity. Okay, so in the propulsion data limits, you can see all of these values, also per engine. So you can read the low amber, low red line. This is not an exceedance. It's just how the indication is presented in the screen. Also in the propulsion page number 2, you can see more values, so you can even see here what's the oil level status. So this information is here in one, and the number two is what will show vibrations and quantity among many other types of information that is this screen is showing. Okay, now this next one shows how some of the other components interact with the computer when it comes to engine indicating. Say for vibration, our RCCs will get information from bearing number 1 and turbine. Yeah, the number 1 bearing excel in turbine acceleration signals. So RCC will convert whatever values here, so the ABM can read it. So once the information is ready, it's sent and exchanged with AIMS, and also this N1 and N2 sensor will send their values to the EEC, and through the EDIU, information will pass on to AIMS and so on. Also, T49 will inform directly EECs for whatever it is reading. So the next chapter is oil, but I believe this is about launch time for you guys. So let's stop right here, and when we come back, we start with this, and I will show you some videos also from the GE factory about some of these engine oil system related components servicing or maintenance. Okay, guys. So I will meet you in an hour. So have a good lunch.
Thank you. Thank you. O sea, Don't stop.
Yeah.
How's that? That's all important. Complication.
Yeah.
Then they went to a jet show. It's so far jet show like 2 times. And then, see, the jet shows.
They have this line, those and gun shows. But I got a little, and love those.
Yeah. But the gun shows are doing business. Time.
Those are also.
One, use one. That's a gym show, we got some stones and stuff. Él me hizo, digamos, lo que está aquí. Vamos, te digo, güey. Que saltan y la gente cada uno, entonces las electricas de la reserva. Cada uno trata un número, pero de estas, las armas de las electricas, si tú pierdes, no tienes son menos 20, pues por eso es muy importante. Y ya, es más, si pierdes, pero yo tengo una carta que debe ser, y no, que no es muy bueno. No va a cambiar ese valor. Sí. Güey. Era que no, cambiar las pero no tiene cuánto era mal. Yo era verde. No, era mal. No. Ya no tengo besos de los hoteles que tenía. Debes comer, güey. No tengo eso. No, güey. ¿A dónde más, güey? Invítalo, por favor. ¿Y eso? No. Yo traigo comida. Y mucho siento. No, pues ¿más prisión? Y ¿qué puedo meter los dientes? No. ¿Cuál será? No, no, partir del jueves. ¿A partir del jueves? Bueno, el miércoles vamos a trabajar, ¿no? Tenemos revolución de motores. No, instalación de motores de Skype. ¿Cuándo? ¿A partir del miércoles? Sí, según uno llega hoy y el otro llega mañana. ¿Qué temas vamos a tener? No sé si de la dicha, le vamos a dar seguimiento a nosotros. Pero digo, igual estamos, entonces, yo también cuido.
No, igual, o sea, no tengo problemas si, por ejemplo, me voy al viernes, no hay bronca. Ya miércoles, jueves, le damos macizo.
Pues, jueves.
Sí.
A mí me gusta que
No. No, igual el efectivo le damos miércoles, jueves y viernes, y el viernes saliendo, ¿no?
ya te tomas que lunes, martes.
Ah, y ya tomo los de lado. O sea, en vez de pedirlos antes, los hacemos después.
Sí.
No, no. El viernes saliendo.
¿Dónde tienes el chapuzán?
Sí, por Tijuana.
Sí. Te digo, no sé, la licha, no sé si le vamos a dar seguimiento a nosotros, no sé en qué estatus está. Yo creo que entre hoy y mañana voy a dar una vuelta para allá, para ver qué rollo, pues, para ir a ver a Brando, que nos diga qué rollo, cómo va a estar. Si no, ahorita le pregunto a Tips. No tiene que regresar, si para realizar los proyectos, no sé qué hace un torno a ver y actualizarnos ahora nosotros de cómo vamos
Sí, pues sí.
a continuar. Estamos bien con él, a ver qué está todo eso. Ajá. Eso. ¿Tú estabas viviendo allá antes de venirte para acá o qué? Ah, estamos chambeando ahí en Tijuana. De las Volaris, unas Volaris, ¿eh? Sí. Volaris, Tijuana. Andaba ahí un cuate, ¿cómo se llama? Era soldado. No, cuando yo lo conocí era técnico, no me acuerdo cómo se llama.
Había varios. Los soldados. Pero ¿cómo era?
Digo, alto, blanco. Y la boca. Yo conocí en el 18. Por ahí a mediados del 18 se cambió para acá.
Ahí.
Tijuana,
¿Dónde estaban?
México.
¿México?
Cambió a Tijuana. No me acuerdo cómo se llama. ¿Tú tienes niños? ¿Tienes niños? ¿Tres? ¿Tíos?
17, 10 y 5.
¿Nunca los traes para acá?
Ahorita no, porque estoy haciendo un papeleo para que puedan entrar.
Ah, es que tú eres de acá. Estás arreglando de su residencia.
Residencia.
¿Tú naciste acá? No sé.
Sí. Austin. Austin, Texas.
¿Dónde?
En Austin.
Austin, Texas. Pero tus papás son o sea, son mexicanos.
Mexicano.
Estaban por acá y naciste acá. ¿O cómo?
Sí, mi mamá. Era que le gustaba viajar. Pues nunca se imaginó que iba. Y pues ya cuando estuvo ya iba a viajar y dijo, no, quédate, ¿no? Más tiempo pues, quedarte aquí. Ah, bueno.
¿Qué haces?
Sí, pues no.
Está chido, ¿no?
Sí,
Que pues ya te ahorraron ese papeleo, que la visa, que nada. Una vecina ahí donde vivíamos en Monterrey, tenemos unos vecinos, estaban chavos también, así está la vida. No, estamos chicos, creo que eran ellos. Pero ellos lo que hacían, creo que tenían familia de este lado, de la esposa. Entonces la esposa se embarazaba, estaba embarazada, se venía para acá. Ya en los últimos meses se venía para acá. Y acá se anunciaba, ya se iba para allá. Y luego se embarazaba otra vez. O sea, cuando ya les estaban, o sea, se venía embarazada. Venía, hacía acá y se iba. Y la otra vez, tienen tres, creo. Cuando yo los conocí tenían tres. Y los tres, bueno, cuando yo los conocí tenían dos, que platicaron que así hicieron, que tenían acá y por ahí. Y luego yo la conocí cuando estaba embarazada, y también dijo, no, sí, me voy para allá. Me voy para allá y allá nace. Ya está chido, ¿no? Porque ya tienes
Oye, pues ya viene
para tu futuro más adelante.
la oportunidad. Por eso la tengo los hijos igual. Pero mi esposa, pues ya, tienen forma de trabajar ya sin peligro de nada. No, no, por problema.
Tú tienes ambas, ¿no?
¿No?
Está chido. Pero nunca habías vivido tanto de su pecho.
No,
Bueno, ahorita.
bueno,
¿Dónde conociste al Nacho?
Nacho,
Al esposo de Mariana. Fueron en Volaris también en México. Que también es de acá. La tienen a su acá. ¿No? Pero también es, creo que tampoco había venido para acá. Esta pues también hay una ventaja, ¿no? De que pues, ellas se casaron ellos dos y a ella pues ya tiene manera de venir a trabajar también con él.
yo también, luego mi esposa, digamos, termine, ya soy empacado o algo, pues también puede trabajar ahí.
Alma, por ejemplo, Alma Ferraro, la viste por ya ves que ellos también se llegaron a ese igual. Ellos igual, pues ahorita ya sacaron su residencia, ahorita ya son ciudadanos.
Nada más está, o sea, digamos, está bien en cuanto a la familia esté bien, porque les manda dinero y se lo explica, ¿no? Pero ya cuando se vienen para acá, ya es gasto de veras. Serían todos aquí, y es lo pesado. Pero en realidad entre dos, además, pues, aquí.
Pues de ellos los dos trabajan. Alma, su esposo, su chavo,
Sí, pues ya.
todos trabajan. ¿Y dónde ves el lado tú? O sea, ¿dónde te criaste?
¿Dónde?
¿Dónde te criaste?
Ciudad de México,
¿Luego ahí te moviste a Tijuana?
salimos muy pequeños. Sí, todo. Ciudad de México.
Y antes de volar, ¿dónde estabas?
¿En serio?
¿En México?
Listo.
¿Saliste por lo mismo que se paró todo?
No, antes porque me empezaron a trabajar con él. Y mantenimiento. Carmona. No,
Daniel Carmón.
no entramos. Vente para acá, cabrón. Bueno, yo fui a una entrevista y ya, bueno, lo conocía anteriormente y pues, me dijo, me entrevistó, y a lo mejor después, pero estaba chupando. Ahora tengo ya. Bueno, pero hice más que estando en Centinela. Centinela era, bueno, pagaba bien, pero hice más en Volaris.
Y luego por estar en Tijuana, que te dan un poquito más, ¿no?
Ajá, un bono de vida acá, y un poco más de sueldo. Y tal.
Ahí. Conmigo se enojó el camarada.
¿Sí?
Digo, a mí me dio chance porque yo no tenía nada de experiencia con pues, de aviación comercial, ni aviones grandes, ni nada de eso, ¿no? Ni línea, ni nada, ni tenía experiencia. Era directora de corporate jets, de aviación corporativa. Me dio chance a él y sí, ¿no? Pero cuando me salí, sí, que no vaya, hermano. Pedimos la oportunidad, los cursos, pues, es que no me puedo negar, pues. O sea, ella pilló, o sea, no, yo ya tenía 3 años buscándola. Y apenas tenía yo 8 meses ahí por la. No me gusta, pero podemos decir es que no.
Sí.
Pues es que no. Dice, un poco mi bien. Fue chido.
Sí. Bueno, o sea, sí es gacho, pero como amigo, sí. Ya de repente, sí, a muchos les queda bien el gacho.
También como me dio la oportunidad, pues yo lo tenía en buen.
Ajá, también igual.
Yo se por todo.
Porque de hecho el que trabajaba ahí, el que trabaja más bien, mi hermano, por él es de Río, y me decía, "Vente para acá". Y cuando yo estuve en la entrevista, ya no fui porque mi hermano me haya conseguido algo así, sino yo fui ya dentro con él, me entrevistó, y sí, ¿crees en esto? Sí, pues sí, ¿no? En inglés, ¿cómo anda? Le digo, ahora nomás, necesito, pues que tengan inglés, así, ¿no? Y iba pasando mi hermano, ahí por la oficina donde está entrevistando, y me ve, y mi hermano salió. Dice, ¿qué es el colegio? Sí. Y le habla a mi hermano. ¿Lo conoce? Sí, es mi hermano. ¿Y por qué no me dijiste, cabrón, que no sé qué? No, yo no sabía que él iba a venir. Ah, sí, sí, bueno, ninguna exactitud. Y ahora le puedes, ya me enseñó, pues, órale. Sí, claro. Me gusta. No, de empezar a poner estudiar, no, de que te vas a poner estudiar, te vas a poner estudiar y. Pero pues estudiar, ¿verdad? Pero a mí no. No les pedí, por favor. Ya me dio chance, pero me fui allá.
¿Cuánto es ahí?
Casi 5 años. Le va a volar al tiempo. Sí, pero ahí luego compré mi casa, todo lo que tengo en México, no había hecho, ¿no? Ya luego.
¿Usted en tu casa en Tijuana?
Sí, sí, no, ahí sí, compré 3 carros, la moto, compré la casa, fui a vender, le compré la camita a mi esposa. No, sí, la verdad sí, me fue muy bien. Muy bien.
Sí, claro.
Digo, en realidad tampoco sí me dio mucho también, pero casi bien mucho el diferente. No, si el motor llegan, el miércoles seguimos niños. Yo creo que en 2 días lo subimos, un día y otro día, para que el viernes hagan puras pruebas. Ayer en Morales con 4 o 5 personas subíamos, bajábamos, subíamos, un día ya.
Sí, me tocó a mí un PW1100. No, tenía que ir a bola.
Yo estuve en el proyecto de Diego, Tijuana. Ahí estuve viendo el proyecto, donde llegué, estaban los componentes y los mandaban a probar. Llegaban los aviones, bajábamos el motor y suben el otro. Claro que se quedaba, Yeah. Así, sí, éramos cuatro. Más no, revisor. Ya sé que mi hermano va a entender para hacer conexión. No. No, there was going to give me several options for the bank, we spent as well.
Por lo menos, los prepagos, ¿no? Ya tenemos prepagos ahí. Te digo que hay un carrito va a contar, ¿no? Cuando se paga.
I told her that here. Yo me leía en la mesa. ¿Qué creen que la voy a pagar? Porque no tenía, no me exportaba lo del federal. No. Entonces, a lo mejor voy a leer como 3,000. Pero bueno, no ver eso. Ahora que me dice que no creo que la solución va, pero por lo menos a ver si puedo pagar en parte.
Que te ayuden ahí también.
Pues a ver qué me dice. Well, just no what since I started the year.
Déjame ver, bueno.
I just check. And there's something that had to cover the deductibles. Control. Yeah, 16 minutes. I'm sorry, say again. I know, I don't know, every paycheck comes with more than years than less.
I would get that and it's here.
Yeah. Um,
That the children hadn't arrived home after school. I thought they kind of flat tire, the bus was broken down or something like that. They're maybe. I think so. Sure, so almost that part of it, sure, Chelsea.
Hello.
In a small county, but showing the same. Yeah, but you take off shoulder line. Get a check.
Yes.
Yeah, there's a street. Every which way. Didn't see anything. Station.
Wow. Right now, for the individual is 1,600 and for family is 3,200. Yeah, for doctor visits, the readings, let me see. Office visits, 20% of the deductible, virtual $5 school pay. Okay. Oh, thanks for the advice. Oh. Sure, thank you so much. All right, thanks, bye now.
I think that they believe that. Yes. And I didn't want to. But I died in my knee. It's not getting here.
They asked me maybe I couldn't go else with my orders. So I was there with them. And that's how they, you know.
They have really energies and super certain that their wives will be about the it's my personal way of the first channel I have that book and I don't like to do that's a person and video in your address of children in your family. You can't be out there the issue of the partner choose plan it's hard versus you have to and I don't know that it and I can handle
and I can see that right. And I didn't follow one thing, you know, I knew if I would tell them, I was never having back out. And then that's right. Price one eight level, because it's going to go down. And it wasn't going to in there.
it's my this whole creative the dark vision and they're really comprehensive and have to wait where to work. I have my brother cited that he would go on there and seriously there. When they had monitoring that there, going to see and they yelled so they bring line and the Jimmy had to say this for the whole world. Giant they understand calm someone's and composed. And which is now personality. There's this figure and everybody there to help. And that was they had very independent friend.
The rest of you start to cut out the
I put okay, these friend, okay, all by, back together.
suddenly they get wrong, loving me, I don't know. Every birthday, I loved it. And it was kind of like the gifts way right by again. And it was a fancy, it was late and it's a little point. And I tell Joe, it was there actually covered. Have any idea you might have done it? See, if the sheriff says the only thing he is really looking is the possibility of this also, and the release to the survey, which is really not the possibility either. We have very few areas. I remember talking to Roberts, the late body, that's free. Actors, it's just because everybody please, please, places them, it's just everybody here say pretty please, so we have to say that. Muchas veces para ver sus propias creencias o creencias para preservar el patrimonio cultural. Las personas de la quien se vuelve el presidente, yo creo que por eso usted quiere ser la cabeza de la si usted se lo quiere, usted tiene la not before
And they had a giant surge, 26 California children, are now victims, only an eerie silence, like they get disaggregates. When you visit a parent and other family, anything the man goes out and downtown Young. At that time, there was another people waiting for her, and it was CPR. Much of its best evening, guys, and suddenly it's the state police that is necessary, and that you are available to assist in the search. When somebody disappears, you have all when you have no work whatsoever, or they might be, you should down. You want to he was a gentleman, and the counter standing, he was practically in tears trying to get home. I was able to sleep for a while, but as soon as I opened my eyes, it was like kind of breaks in me. There's no thing was to try to pay. I was one once. There was a policy and pray hard and there she would come. And Dad, he's trying. Gotta try to get it done. Gotta get it down. And stay there. And just like the band to stay out there and keep running. And she was there for a few weeks. Could cause harm, not only taking it, but tonight. But my 10 had anything to do with that. You know, you're getting independent to get serious anymore. Tower. That little process, and I thought to myself, we're gonna die, get the hell out of here, we're gonna die. He's just thinking of answers this kids in talk. And even a lot of the younger kids have turned to whatever it is that their younger bodies can do. We're not going to die and not have work in it. The German's job was to try to flush the brain for my own. Things changing, jumping, flush. And that way, and then you have to, got here, now I'm going to keep here. She was here, and he was up there sleeping.
And brain student issue with everything he had. They knew something wasn't right, but we didn't know what it was. And so he pushed up. And he got that thing with some around. And he got it again. And my Marshall was stuck his arm like her. I sort of feel like I have to see that was on top of the game was over. Like, guys, I didn't know. And just people listen, get together. They have the most of the baptism. That's better. It's not that great. But it's and every is just regular. And if it's able to take today, that's a pass. People try to think my hands. You're I said, it's up on the try and he part going to bring in like time under severe conditions, support the most vulnerable senses that we can. Check the health of my people for the long time. I was making drained, tired, and energy, so my equilibrium was totally off, that I didn't know what was up, That's when it just started. Great cities don't hurt it. Great cities don't hurt it. You hear every big year train. Great cities don't hurt it. I'm starting to believe that they are up there. That to me was scary. I tried to see if I could get any weight off the top. Like describing. And I looked through it in plain as day. I was going to in a dorm. And beyond there was a figure
This was a hallucination. And it's unknowingly that they were still in horrible trouble, that they were going to die anyway. So he went back down and he sat down and he thought, what am I thinking? This is terrible. I can't do this. And then he decided I'm going to go out there anyway. Right there, but then so I did. I said, I know, what's your count? You're going to be on this. I mean, yeah, of course you're going to do whatever it is you got to do. And here they run there, over there, you know. We have, you see, training, and I felt like we were getting down, nobody there. I remember getting out and looking around. I was at the distance, it wasn't big building. And I was worried about it because maybe conductors probably. People got all the kids together and homes. And so, like a bunch of little ducks, which is walking through the sand. And somebody shut limits. And if there are any corporations, they started to see. But then we saw something coming. And the giant space was Chat show, they're online everywhere, people everywhere, it's just, you know, people.
It was just, on. Ladies and gentlemen, very beyond the bus.
It's not, they disappeared. The children at Shasha returned to their parents. Due to the football campus, their muster and ready.
That person was still out. No answers.
You what? Yeah, P, you wanna help me? I'm just, I was a kid. Later. Later, okay, okay. You? Yeah, ain't you a DI? Designated inspector? Designated inspector. Inspector training. That's you? Yeah, I got it. Oh, I got it on my track. I haven't done it yet. Oh, come on, get your first one. You're like here in the bathroom. Yeah, you got it. Well, I got breakage. I thought he was serious. I know. I thought he was serious. Yeah, somebody. Year was at that time. What year? Seventy something, 70, I think. Here's what I've heard the story.
She sent you the link for tomorrow? Talk to him?
They canceled the, I'll be here. They canceled the, July 15th, 1976. It's the name of it, the 2000. I wasn't hearing about it. I was living in California at the time. That's Central California. I think I was in northern and southern. But northern from the school time, school that I was down to San give up the state and African fun. Actually, in the place of the it sounds good. Not that one, amazing places.
Gentlemen. Good to see y'all. Good to see y'all. Good.
You have the one day?
Tuesday. Oh. I think my feeling fell out. It's all exposed. I'm gonna go. Take a look at it, see what's going on. Hopefully they can fix it. Yeah. They'll be there at 2. And I'm like, hour, 20 minutes from there. I see y'all in March.
All right, well, see you tomorrow, man. Yes, sir. I need my prescription.
Very fine. That's 07-2.
Yes, I was living in Seattle. In Ted Bundy was on the list, and I remember I often getting his gun out. Physical. In a holster, was out there looking for him because a helicopter was right above us looking for Ted Bundy. I seem to be in a lot of lists. The LA riots. I didn't live there, but my dad managed 1,000 units of storage out there. Yeah. And I just happened to be visiting him, and he happened to be leaving. No. For the week or something like that, so just my sister and I. And so I was actually there. Driving around downtown. I saw all kinds of stuff. Cars busting up gas stations and people getting busted by the police. I mean, like, from here to like that chair, yeah, that close. So, right, I guess my dad sent somebody over a couple of boozings. That's it. Put them underneath the seat and drove me around. I don't want you driving around by yourself. My dad was in like that, he had contact with. I never knew what the hell, I slapped him, I didn't know what he did. He was president of Superhero for a couple of years. So. Yes.
Hello, guys. Are you all back already? Almost. All right, so I believe I have another good video to show some things that sometimes happen in the ramp. So let me get it up there for you. It's not really involving the this engine itself, but I just found it and it's interesting to see it. Let me project it.
On August 20th, 2007, a Boeing 737-800 operated by China Airlines departed from Taiwan and had an uneventful flight to Naha Airport, Okinawa, Japan. The 737-800 employs a high-lift system that includes leading-edge slats, which enhance takeoff and landing performance. These slats move on tracks, which retract into the wing leading edge until contact with the downstop assembly. When retracted, the slat tracks are stored in housings which are only large enough to accommodate the slat track. The track housing itself is an integrated part of the wing fuel tank and extends through the front spar into the main fuel tank. Approximately a month prior to the accident, the number 5 slat can had been inspected and reworked in accordance with a fleet-wide Boeing service letter. It was believed by investigators that a washer had been omitted during reassembly following this maintenance activity. The bolt assembly can be seen here as part of the downstop. The washer was intended to prevent the bolt assembly from passing through the downstop, since the nut is smaller than the hole in the downstop assembly. Investigators believe that at some time between the earlier maintenance action and this flight, the bolt assembly migrated out of the downstop assembly and fell into the slat track housing. With the bolt assembly lying inside the track housing, upon slat retraction, the track pushed the bolt assembly through the bottom of the housing, penetrating the main fuel tank, which resulted in a fuel tank breach. Leaking fuel migrated to the leading edge of the wing and was carried aft by airflow during airplane taxi. This photo was taken from the penetrated fuel tank after the accident occurred. As shown, the entire bolt assembly was driven into the fuel tank. After arriving at the designated parking position, leaking fuel began pooling beneath the aircraft. Ground personnel observed this leaking fuel coming from the right side of the aircraft and immediately contacted the flight crew via the cockpit interphone system, advising them of the situation. During taxi, and while the engine was still running at idle, leaking fuel was not able to reach the hot engine tailpipe or brakes, as the cool engine fan exhaust prevented fuel migration at these hot areas. Upon engine shutdown, the fuel was able to drip onto the tailpipe of the engine and onto the hot brakes, resulting in ignition. Flames then quickly spread back to the aircraft, which was eventually completely destroyed by the fire. The airplane was successfully evacuated at the first indication of fire. There were no fatalities or serious injuries. The first picture shows the aircraft during the fire. The second picture shows the number 5 slat track housing following the fire.
You're on that plane. Oh, right. I'm sure you're gonna fly. I dated a girl who used to parachute. They wanted me to go with her. They always trying to get me a parachute.
So I guess that was pretty bad, huh?
Last one, you didn't know if it killed me.
Well, anyway, all right, so let's go back to where we were before. The next chapter is about the oil system. So it consists of storage, distribution, and indicating as well. And firstly, we have, for instance, this oil tank for storage, the lube and scavenge pump for distribution, and the indicating in the secondary engine display screen, and which are the elements, the main elements that provide the system with lubrication fluid. Let's see, if we go and see the tank, well, it's just a reservoir for the engine oil system, and there's a manual gravity field with a cap assembly that is used to pour fresh oil in the system, and the distribution consists in the pressure scavenger breather system. And we already mentioned that there's an ICA screen dedicated for that system indication. Also, there are some sensors like the oil pressure sensor, the temp sensor, and the filter differential pressure sensors involved in this system, and they are arranged this way. So there is a pump, and it is scavenge pressure. It is diverted to all of the bearings. It will pass through the oil heat exchanger, and then you will go to the manual fuel oil heat exchanger, and this is the scavenge pump. Will actually brings the oil back into the tank. So it is not showing the bearings they lubricate, but this is the cycle it completes. Also, there is what they call also the DMS conditioner. This is a debris monitoring system, and it will be collecting any unusual metal particles that could come off from especially the bearings. So we'll see them in a further slide. But in general, this is what supplies the entire system. You have to come to the left side in order to service the oil tank, and it is this one. This is a manual gravity filling cap assembly right here, typical, and the DMS will be right on top of it. There's also an oil level sensor, and you have to remove the cap, and probably it will be bearing like a scale, so you can measure how much oil the tank is containing at a moment. Okay, so the next part, oh, again, I said you can see it, you can find it on the left side of the engine in the forward section right here. You're at the just after the fan blades area. So it's nearby in the outside. The filling cap assembly looks like this. Here is a dipstick I was referring, and usually there should be a lanyard that will hold the oil, the filler cap next to the tank. So nothing new in it. Here is the scale. So this will tell you how much more oil it requires. So it is said that anytime you go do servicing, you have to top it off. And also we'll know that you have to wait 5 minutes after the airplane arrives and they shut down the engines. And before the next 30 minutes, it is advisable to come and service the tank again. So it has a dedicated door, and you open this one and you can do the servicing procedure as per the usual manner. You can see the indication also replicated in ICAS. So if there's one guy just sitting around the flight deck and is able to cross-check this information, you will see how much more is there. But you actually can use you need to use only this scale. You don't really need to cross-check with the ICAS screen. The scavenge oil, same thing. This is a scavenge oil inlet. Well, this is a scavenge oil pump, and it has some inlet and magnetic blocks, so they can also collect some chips from the system as the oil comes back to the tank. This is the main fuel oil heat exchanger as well, and the oil heat exchanger. Well, probably we will see that in a minute. Now it is showing where you will find the DMS conditioner and the sensor.